Hello everyone. This is Abhishek Pandey on behalf of Group 9 to explain our project, a version controlling system in Python, a clean and maintainable VCS implementation. So what exactly is a VCS? A version control system is an application which allows you to store snapshots of your project at different points of time and to go to any of those snapshots at any point of time when you wish. This allows multiple people to work on a project together and also allows you to roll back your project some days back or even some months or years back if you find a bug. Every change made to the project is tracked. So if you made an unwanted change at some point of time, you can easily remove it. Basic features. What are the features of a VCS? The main feature of a VCS is to make sure that there is a snapshot of the state of the project at every point of time. It also allows you to access every snapshot of the project. And you can, as we discussed earlier, roll back. So this diagram pretty clearly shows what the function of a VCS is. Initially, you can see we have three files, file A, file B, and file C. In the version 2, we changed A to A1 and C to C1. File B remains unchanged, so we are using the same contents in version 2. This allows us to save space. In version 3, we have A1, B, and C2. So only one file has changed. This allows us to reuse two components, A1 and B, from the previous version. In version 4, you can see that A1 has changed to A2, B has changed to B1, and C2 is the same. So this allows us to reuse one component. In version 5, as you can see, A2 is the only one unchanged and both of the other are changed. So what are the basic features continued? As a version control system, it has to allow you to share your projects with different sorts of people. It also allows you to merge different change sets from different people. Actually, this is how the Linux kernel project works. People send their change sets to Linux torvalds, and torvalds merges the patches he deems necessary. VCS also allows you support for tagging and branching. Tagging because you can associate a particular version number with a particular point of project. What is the workflow of a VCS? Your local repository contains several trees maintained by the VCS. The first one is your working directory, which holds the actual files. The second is the index, which acts as a staging area, and finally the head, which points to the last commit you have made. Branching. Branches are used to develop features separated from each other. So now let us look at the code. All Git commands are classified into two categories, plumber commands and porcelain commands. So what are these porcelain commands? The porcelain commands are wrappers around the plumber commands. The plumber commands are the low-level commands. So there are four basic porcelain commands which we have used here, like add, commit, init, and status. All of these are mapped to a particular function using a dictionary. This is the main functions which gets called if you call the file directly, porcelain. And this is the file actually which is deemed the Enigma file. Now we have the plumber commands. These are the commands which directly interface with the file system. The first of these functions is git get dir. It returns the full path of the ENI repository in which the current directory is being tracked. Return full path of the ENI repository. Then we execute a couple of commands here and there, as you can see, to maintain the Git directory and other species. Then there is a function to get to the relative path. As we know, Git always shows you the paths. Then there is a function to show you the changed files. It shows you all the files which have changed from the last revision. Then there is a git hash function. As you can read the documentation, this function returns the SHA1 sum of the given string. It assumes that the given string is UTF-8. We choose UTF-8 because it can be used to express any human knowable language. So what are the parameters? The parameter is only one content, which can be any string. The return value is SHA1 sum of the given string. Then there is another function get store. It returns the content to be stored in the Git. It does so by appending the header specific to the blob type. Parameter object type, the object type of the string. Default is blob. Return the string which will be stored in the Git object store. Git hash file. It returns the SHA1 of sum of the blob corresponding to the current content of the given file. Parameter file name, which can be any file. Return the SHA1 sum of the corresponding blob in the Git object store. Make dirf not exist. It creates a directory if there is no directory by the given path. Git write hash file. It takes as input a file name and writes a blob to the Git object store with the current contents of the file name file. Parameter file name, the name of the file which you wish to store in the Git object store. Git write hash writes a blob in the Git object store with the given content. Parameter content, string to be stored. Return SHA1 sum of the blob created. Git get content returns the string contained in the given file in the directory .ini/objects. Parameter file name, full path to the blob in the Git object store. Return string stored in the blob. Git blob type returns the type of the blob stored in the given string. Parameter store and compressed value contained in a blob. Return type of the blob. Git get store gets the decompressed value stored in the blob at any decompressed content in the blob. Git get file, this is the main function. It returns the string to which the blob of SHA1 sum corresponds to. SHA1 sum is quite long, about 20 bytes as we all know. So you don't need to enter the complete SHA1 sum. You can enter a prefix, which an unambiguous prefix, which allows us to detect carefully which location you are pointing to. There is an error when there exist two blobs starting with the same SHA1 sum. Then there is git init and git store and git cat file, and that is pretty much it. As we all know, this model is completely decentralized. So if you clone my project, mine and yours are no different. You have the same history, I have the same history. Whether yours is mean or mine is mean does not matter. Both of us use the same copies. Motivation to create a version control system in a collection of high-level languages. What will be new? You can override any of our functions at runtime. How? This is the config.py file. So if you don't like the way we print or your status or the way we store something or any of the functions you want to override, you can simply define them here. For example, if you did not like our get cat file function, you can simply do get cat file. Yours, do write your custom code here. And we will be printing files according to your convenience. So if you want to page the file through a pager, or if you want the file to be displayed in a browser, you can do anything you want. So this you can use toml or yaml to provide init configuration. That can be done. UI in supported platforms, as it is written in Python, it can run on any platform which is supported by Python, which is almost all, because Python only needs the glibc runtime. So any platform that supports the glibc runtime can be used.